Hello. Now, we are going to continue on with our work in area and volume, and this is actually our last point on area and volume. We're going to be looking at the trapezoidal rule. So, trapezoidal rule effectively comes in anytime you see a curve like this one, so a hill or a curve of any kind, and you see it broken up into a bunch of sections with vertical lines. If you see that, you're immediately going to go to page 12 in your log tables, and you're going to use this formula here. This formula is called the trapezoidal rule. And because this formula has lots of bits and pieces to it, they only ask very straightforward questions with this, because it's complicated enough that they don't want to make it undoable. So, anytime we see a curve like this broken up into equal pieces with our vertical lines, we are automatically going to go and look for page 12, and we're going to look for the trapezoidal rule, which is in the middle of that page. Now, in that, they will give you a picture that looks exactly like this, and they're going to give you this area formula. And what we're going to do now is talk about the different parts of this area formula. So the gap between the vertical lines is called h, and we have the area is equal to h divided by 2. Then we have a bracket. We have y1. Now y1 is the height at the very beginning of our curve. So this is our line that we're measuring from, and this is the y1 is the height up, the length up from our measuring line up to our curve. So this would be y1. And if we look at question 2, which is the question we're going to actually be doing as an example, you can see that y1 would be 0, because our curve actually starts right down at the measurement line. So if we measure up from our measurement line up to the curve at the beginning, that distance is 0. Then our y2 in this case would be 10, and our y3 would be 21. So our y2 is our second length, our y3 would be our third length, and we keep on going however long the shape is, however many of these lengths we've got. And when we come to the very end, we call that length yn. In this case, yn is 12. It's our last length. So if we remember back to our series questions, we had n would have been the number of terms in our list, and it means basically the same thing here. So this is the last length in our list. So here it's 12. In our list, the number before the last is n minus 1. If you remember, that would be the second to last number in our list. And our second to last length in question 2 would be the length 14. So now we've got our different pieces for our formula. We're going to have a look at question 2 on page 268 and see if we can figure out the different parts. So I see I have a curve that's been broken up into lots of little pieces. So I open up page 12 in my log tables and I write down this whole formula. Then I'm going to find what each of the letters are in my question. And remember, in the log tables it gives you this picture, so it reminds you of what the different letters are. So in this case we're told that our distance between our lines is 12 meters. So h in our formula, h from our formula, is going to be 12. Our first height at the very beginning in this case is going to be 0, because the distance from our measurement line up to our curve at the very beginning is 0, because the curve is on the line. y2 is our second height, and it's going to be 10 meters. y3 would be 21. Now I haven't bothered to write down y3, but you get the idea. We keep going on through. And our last length is yn, which is 12, and our second to last length is yn minus 1, which is 14. So I've written out everything I need for my formula. Now I'm going to write a is equal to h is 12 divided by 2, open up a bracket, y1 is 0, yn is 12 plus 2, so y1 plus yn plus 2 times y2. y2 is 10. y3 I keep adding them all up. So I see my dot 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 here means I keep going until I get to yn minus 1. So 10 plus y3 would be 21, plus y4 is 26, plus y5 is 30, plus y6 is 28, and the next one is 26, and my yn minus 1, my second last length, which is where I stop, is 14. And I now have all of the different parts of my formula filled in. Now you can just put all of that into your calculator, but the chances of making a mistake are quite high in such a big mess of a sum. So what we're going to do is simplify out each bit in turn. You're not required to do this. I'm recommending it so that you don't lose marks for making a mistake. Because if you show your steps, you're guaranteeing marks if the examiner can see what you were doing. Now all I've done in this line is I had 12 divided by 2 in my calculator, that's 6. 0 plus 12 is 12. And then I added up all of the numbers in this list and I got 155. Now I'm going to go 2 by 155, just working out each little piece of this as we go, and I get 310. And I add 12 and 310, and I get 322. And I multiply that by 6 and I get 1932. And my units are going to be, remember I'm dealing with an area and I'm given units in meters, so area would be units squared. Meters squared is going to be our final answer. So if we follow the steps, as I have been saying to you throughout this chapter, write out the formula, write out each thing you're going to sub in, and carefully sub in and simplify it down, you'll get full marks for these types of questions. And that's all we need for now.